I was talking to a Calc 1 student about trig derivatives. And it was a list that was something like this, but it was all in a different order. And I said, it's all jumbled up and it doesn't make any sense. And it seemed like an odd thing to say because isn't this just a list of things that you're supposed to memorize? And why would it have to have an order and make any sense? And I think that pattern recognition actually makes it a lot easier. So I would like to show you the list that I would make and why it's not jumbled up anymore and why pattern recognition makes this a lot easier. Starting with Pythagorean identities, this cosine squared x plus sine squared x equals 1 is one that you should be very familiar with by now. So sines and cosines, they go together. Take the derivative of 1, you get the other stuff. And then 1 plus tangent squared of x is equal to secant squared of x. Those go together. When you take the derivative of tangent and secant stuff, you get other tangent and secant stuff. Cotangent squared x plus 1 is equal to cosecant squared x. When you take the derivative of cotangent and cosecant stuff, you get cotangent and cosecant stuff. So the groupings go by Pythagorean identities. So color-coded here, this one, those stuffs go together, these go together, these go together. We're not mixing and matching outside of our Pythagorean identities. Another thing is that whenever you take the derivative of something you get a negative answer. So the derivative of cosine is negative sine, of cotangent is a negative cosecant squared of x. Derivative with respect to x of the cosecant of x is a negative cosecant x cotangent x. And so all of the co-derivatives, if you were taking the derivative of a co-thing, you should get a negative answer. And when you're taking the derivative of a not co-thing, you get a positive answer. Now, this is also how these are organized when looking at the tangent and secant stuff and the cotangent and cosecant stuff. When you take the derivative of a thing that was a fraction of your sines and cosines, like your tangent and cotangent, then the answer is a squared something. So we know that if you are dealing with tangent stuff, you should only get tangent secant kinds of answers. So this one's going to be secant squared. It's the other thing squared. And with cotangent, you get negative cosecant squared. So if it is a thing that was built on a fraction, then you should get a squared answer. The ones that were just the reciprocals, not both pieces together, but the reciprocal of one or the other, like the secant is the reciprocal of cosine, and the cosecant is the reciprocal of sine. When you take the derivative of those, you get a product for an answer. So, Pythagorean identities, those things go together. Cosines and sines go together. Tangents and secants go together. Cotangents and cosecants go together. Cos stuff has negative derivatives. When you take the derivative of something that's built on a fraction of sines and cosines, you get a squared answer. When you take the derivative of something that was a reciprocal of one of the originals, you get a product answer. And they all go together logically. It's also relevant to point out that I'm not showing you the proofs of how to get these. It's just kind of a pattern recognition situation. That would be a much longer video if I had to do all the proofs. Not against it. Now, these Pythagorean identities also make sense because you start with your Pythagorean theorem, and in an algebra class, you go from geometry to, okay, let's take this Pythagorean theorem and put it on a Cartesian coordinate plane, and you get the distance formula, and then eventually all the points that are equidistant, and then you get the equation for a circle. And then you take this thing and, your horizontal spaces, your vertical spaces, and if you look at a unit circle in a college algebra class, then you end up with x squared plus y squared is equal to 1. Algebra done. Then your x becomes, in a trigonometry class, a cosine, so your x squared becomes a cosine squared, your y squared becomes a sine squared, and 1 is still 1 because that's the radius of a unit circle. So Pythagorean theorem gives us this in an algebra class, so geometry is this, algebra is this, trigonometry gives us this. And then if you take everything in here and you divide it by a cosine squared, then cosine squared of x divided by cosine squared of x is 1. Sine squared of x divided by cosine squared of x is tangent squared of x is equal to 1 over cosine squared of x. You get a secant squared. Similarly, if you divide everything in your original Pythagorean identity by sine squared of x, then this one becomes the cotangent squared of x, this one becomes the 1, and then this one becomes the cosecant squared of x. So the Pythagorean theorem gives us the equation of a unit circle in an algebra class, which gives us this Pythagorean identity in a trig class, which gives us the other ones also. Now, one last little thing here. Sometimes I say, well, it just makes sense that the derivative of a cosine is the negative sign. And just look at the graphs of them and what I mean by that. Okay, so the red one is the cosine function, so this thing right here. And the blue dotted one is the sine function right here. This green one is the tangent at any point that I'm specifying right here. So, I'm going to move this one. You see how the green line is tangent to the red function, that's the cosine. Okay. Now, the value of cosine is positive. We don't care. What we actually care about is that the slope of the tangent line at whatever this value is negative 1.3. The slope right there is positive. Now, the slope is positive. What is the actual sine value? It's negative down here. So the derivative of cosine at that point is positive. The slope of the tangent line is positive. And the equivalent sine value at that place is a negative number. They're the same number, but they're additive inverses of each other. In other words, they're the same number, but with different signs. This is kind of a brain bend thing, Like, I'm just like, it just makes sense. And then people are just like, which one are we talking about? Okay. That was a little confusing to see. Let's do that one. Okay. Right here, the slope of the tangent line, the line tangent to the cosine function, is negative. It's going down. The first derivative at that point is negative. The slope of the tangent line is negative. The actual sine value at that point is a positive number. The y value, or the g of x, of the sine value is up here, is positive, is above the x-axis. These are the same number with different signs. It doesn't matter where I go, these are going to be the same numbers with different signs. So the first derivative of the cosine function is going to be the same number with a different sign of the sine function, and that is why, that is a graphical explanation of why the derivative of cosine is negative sine. Whatever the green slope is, the sine value, the y value of the sine function is going to be the same number with the opposite sign. So, right here, the slope of this green line is a positive 0.37 blah blah blah, and the actual value of the sine function is negative the same thing, negative 0.37 blah blah blah.